हेलो माय डियर मैकेनिकल इंजीनियर्स, हाउ आर यू ऑल? व्हाट्सअप, कैसे हैं सब लोग? प्लीज डू जॉइन मी फास्ट गाइज, बिकॉज वी आर गोइंग टू डिस्कस द मोस्ट इंपॉर्टेंट 10 क्वेश्चंस from the basics of thermodynamics and the first law of thermodynamics. So please do join me fast, and those who are already here, respond through the comment section if my audio and visual quality are fine. If you face any issue in audio or video, please do let me know through the comment section. Otherwise, please write yes in the comment section if everything is fine. Keep your pen, notebook and calculator. Try to solve as many questions as possible on your own independently. So the session will become more beneficial when you have a prior revision of the topic which we are going to discuss. So I will be covering the basic definitions, general definitions of which are used in thermodynamics, then energy interaction, heat and work, and some questions from the first law of thermodynamics for a closed system, open system, and steady flow process as well as unsteady flow process. Hi Rajput, welcome. Good. Everyone else, those who are here, please, it is my humble request, do write something in the comment section so that I also get motivated and we start our unique and important session. And in case of any difficulty, you just let me know through the comment section. I will be more than happy to help you out if you have any confusion, any doubt in any of the concepts. So this is my quick introduction for those who are meeting me for the very first time. I am a mechanical engineering graduate from IIT Delhi. I have also cleared engineering services examination which is conducted by UPSC. I have worked in Steel Authority of India Limited also for a couple of years. And from last 11 years, more than 10 years, I have been into teaching, guiding the students who are preparing for various competitive examinations like GATE, ESE and other PSUs. And I am very much comfortable in fluid mechanics, heat transfer, entire thermal engineering as well as the industrial engineering. So if you have anything to discuss in any of the mentioned subject, then I will be more than happy to help you out. You can always connect with me through the mail ID. As you all know, very less time is remaining for your GATE examination. So in the next 3.5 months, please give your fullest. Give your 100%, more than 100% in revision as well as in practicing as many numericals as possible. Nobody can stop you from getting the success in your exam. You can join me on the Telegram. There are already so many students who are part of my Telegram channel, and you can scan the QR code which is there on the screen, or you can join me by using the link mentioned below. Or if you are not in a position to join using the link or scanning the QR code, you just search me on the Telegram, Mechanical by Chandrasekhar. Then you can join the channel. So many students are already part of my Telegram channel because we are providing you so much information which is important for your examination. The PDF of this session will also be provided to you through the Telegram channel only. So it will not cost you anything, but it will help you to improve your preparation with competing with your colleagues, with your peers who are part of Telegram channel. All right, shall we start? जब तक हम start नहीं करेंगे, जब तक every one of you mention your presence in the comment section. How are you all? What's up? Give me thumbs up sign if you are here with your pen, notebook and calculator. I will show you the first question only when you will give your presence by writing in the comment section. Only AL Rajput had mentioned. What about others? बाकी लोग हार्ट साइन कौन दे रहे हैं? There will be a scholarship test which is conducted by BYJU'S on 29th of October, that is coming Sunday, from 9 a.m. to 9 p.m. Hi Ram Yadav, welcome. Good evening everyone. Once again, I welcome you all from the bottom of my heart to this wonderful session. It is my humble request to every one of you, please do participate as much as you can. Please share your knowledge, ask me your doubts, share your opinion and try to solve the questions. That is the most important thing. You can get maximum out of the live classes, right? So 29th of October, mark the date in your calendar and do not skip this scholarship test, because based on your performance in the scholarship, you will be able to get our courses at a discounted prices, right? So let us start with question number 1. Very simple but conceptual question. For an ideal gas undergoing a throttling process, let me see who will be the first one to give me the answer for this question. Yes, who will be the first student giving me the correct answer to this one? Yes, अरे वाह, Ludwig Prantel आप भी है, mute spectator, well done. What about others? Throttling process. What is throttling? Throttling is flow through a restricted passage. Restricted passage. Flow through a restricted passage is called as throttling. Yes, they well done. Ram Yadav, good. Flow through a restricted passage. Throttling is irreversible process. It is very fast. Flow through a restricted passage and the pressure always decreases in throttling, isn't it? There is no heat transfer, there is no work transfer, there is no change in potential energy, there is no change in kinetic energy. These are some of the characteristics of throttling process. Pressure always decreases. So if we apply steady flow energy equation, it is steady flow device. Throttling happens through a steady flow device. According to steady flow energy equation, if we write, let me give you all the information related to this. Look, steady flow energy equation, H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W, isn't it? There is no change in kinetic energy, C1 is equal to C2. There is no change in potential energy, Z1 is equal to Z2. There is no heat transfer, there is no work transfer. Throttling device is used for work transfer. So H1 is equal to H2. So throttling is also called as isenthalpic process. Can anybody let me know the name of the, or what do we call the slope of isenthalpic process? What is the slope of isenthalpic process? So for an ideal gas, if it is an ideal gas, H is a function of temperature only. Enthalpy is a function of temperature only, isn't it? So we can say if H1 is equal to H2 Cp, T1 is equal to Cp T2. Cp getting cancelled out. So T1 will be equal to T2 if it is an ideal gas. Yes, what do we call the slope of isenthalpic process? Slope of isenthalpic process. Anybody is having any idea? Slope of isenthalpic process. So it is del T by del P at constant H. What do we call this? That is known as Joule-Thomson coefficient, isn't it? This is called as Joule-Thomson coefficient. So del T by del P at constant enthalpy, if it is less than 0, what does that mean? By decreasing the pressure, temperature will increase. By decreasing the pressure, temperature will increase. If it is equal to 0, so there is a decrease in pressure, but temperature will remain constant. If it is greater than 0, by decreasing the pressure, temperature will also decrease. That is the slope of isenthalpic process on TP curve, temperature versus pressure curve. isn't it? And for an ideal gas, this is called as mu, Joule-Thomson coefficient. So for an ideal gas, what is the value of Joule-Thomson coefficient? It will be 0 because temperature is constant. For an ideal gas, Joule-Thomson coefficient will be 0, isn't it? So this is about question number 1. Very nice, Ludwig Prantl. Well done, great. Let us move to the next one. Question number 2 on the screen. Question number 2 on the screen. Let me see who will be the one giving me the correct answer first. Everyone, please give it a try. Again, it is for the ideal gas which is undergoing an expansion process. According to the process, pressure into volume to the power 0.5 is constant. What will happen to the temperature of the gas during the expansion process? In general, for reversible adiabatic process, PV to the power gamma is equal to constant. This is the expression for a reversible adiabatic process undergone by an ideal gas system, isn't it? For a reversible adiabatic process. So by increasing the pressure, temperature will also increase and volume will decrease, isn't it? That is, we all know, by decreasing the pressure, temperature will also decrease and volume will increase. That is what we know from the equation of reversible adiabatic. What is the answer? Ram Yadav had said decrease. What about others? Here gamma is greater than 1, isn't it? The adiabatic index is greater than 1. Do you agree? Now, because here gamma is 0.5, that will make the difference. Look, the temperature of the gas during expansion means volume will increase, and what will happen to temperature? That is the question. When we increase the volume of the gas, then what is going to happen to the temperature? That is the question. So our objective is to develop a relation between temperature and volume, isn't it? So according to PV is equal to MRT, it is an ideal gas. So according to ideal gas equation, can we say PV is directly proportional to temperature? We do not want pressure. We want temperature. So P is proportional to T by V. And P into V to the power 0.5 is constant. So replace P with T by V. Into V to the power 0.5 is equal to constant. Can we say T into V to the power minus 0.5 is equal to constant? Are you getting it? Or we can say T upon V to the power 0.5 is constant. Can we say T upon V to the power 0.5 is constant? Or we can say T will be directly proportional to V to the power 0.5. Do you agree with this expression? Do you agree with this expression? Yes, every one of you, please write yes or no in the comment section. Do you guys agree? Ram, Ludwig, Dev, Rajput, do you guys agree? Now, the basic expression, if y is equal to x to the power a, if there is a basic expression y is equal to x to the power a, so you should know that if a is positive, then by increasing x, y will increase. If a is equal to 0, then by increasing y, y will not change. By increasing x, y will always be 1, isn't it? X to the power 0 is always 1, whether you increase x or decrease x. If a is negative, then by increasing x, y will decrease, isn't it? So this, if you relate this with x to the power a, so by increasing the volume, as the volume increases, because A is positive, do you agree temperature will also increase? Isn't it? By relating with this, if there is an expression y is equal to x to the power a, then by increasing the value of a, by increasing the value of x, y will increase only when a is positive. If the exponent is positive, then by increasing x, y will increase, or we can say by decreasing x, y will decrease. But if a is equal to 0, if the exponent is 0, then y is always equal to 1, even if x is decreasing or x is increasing. But if a is negative, by increasing x, y will decrease, or by decreasing x, y will increase. Do you guys understand this? So this can be treated as x to the power a. The right hand side can be assumed as x to the power a, because a is positive. So by increasing x, v, then y will increase, and t is proportional to y. So the correct answer to this question will be, it will increase. Yes or no? Ram, your answer is incorrect. It will increase. It is not reversible adiabatic process. That is how the questions are going to be twisted in your GATE examination. This is the level of the question which you can expect in your actual GATE examination. I hope it is clear. Shall we move to the next one? Shall we proceed further? Please do not forget to like and share this session so that it reaches to all your friends, colleagues who are preparing for GATE 2024 exam. Let us move to the next one, question number 3 on your screen. It is very simple. Give it a try. Question number 3. Air which is having the value of gamma, specific heat ratio, or adiabatic index as 1.4 is compressed ideally. What is the meaning of ideal compression? Ideal compression means reversible adiabatic compression. Ideal compression is reversible adiabatic compression. It is reversible adiabatic compression. From an initial state of 1 bar, initial pressure is 1 bar and T1 is equal to 300 Kelvin to a final temperature of 600 Kelvin. The value of the final pressure P2 will be how much? So it is a reversible adiabatic compression. So it is very simple. We know that for a reversible adiabatic process, T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma is equal to V1 by V2 to the power gamma minus 1. Are you guys aware about this? For reversible adiabatic process, this is the relation. For a reversible adiabatic process, this should be the relation, right? बताइए आंसर बताइए. Don't be mute spectator. It is not a pravachan. It is the practice session. And let me tell you, learning will not be done. Learning cannot be done actually without errors, without mistakes, without failures. So failure is a part of your learning journey. So do not get afraid of committing mistakes. Do not get afraid of getting failed. You should keep your momentum high, learn from your mistakes, learn from your errors, and try to move on. That is how you will become an expert in some time. What is the answer? Yes, Prantal, well done. What about others? So from here we can easily say P2 by P1 is equal to T2 by T1 to the power gamma upon gamma minus 1. So the question is to find out P2. What is P1? 1 bar into T2 by T1, 600 by 300 to the power gamma, that is 1.4 upon 1.4 minus 1. That will give you the answer. It is very simple. Yes, it is very simple. You should memorize this expression. The answer to this question is 11.3 bar. Are you getting 11.3? If the temperature increases, definitely pressure will increase. So all the options are having more value of pressure. As the temperature increases, pressure will increase and volume will decrease. For reversible adiabatic process, as the temperature decreases, pressure will decrease and volume will increase. That is how the reversible adiabatic process happens. Right? Clear? Good to go? Any doubt? Anybody is facing any difficulty? You can just let me know. You can find out the ratio of volume also, V1 by V2 easily. The next question. Aha, this is wonderful. Yes, ये क्वेश्चन का जवाब कौन देगा? क्वेश्चन नंबर 4 on your screen. The question is from unsteady flow process. This question is from an unsteady flow process. There are two types of flow process. One is the steady flow process, that is very simple to analyze. Another is unsteady flow process. Question number 4 का जवाब दीजिए. I want your answer for question number 4. And there is an important announcement. Today at 8 p.m. we will be having formula memory test for fluid mechanics part 1. So after this class will get over at 7:30. 8 o'clock, do not forget to join me for the formula revision through questions. So we will have the test for your formula memory at 8 o'clock. Right? And ask your civil engineering friends also to join this session, because fluid mechanics is common for civil and mechanical. What will be the answer for? If you know the standard result, an ideal gas gamma is 1.39, flows in a pipeline at 450 degrees Celsius, that is the temperature in the pipeline, let me call it as I, and 20 bar, that is the pressure in the pipeline, Pi. A rigid, what is the meaning of rigid? Volume is constant. Insulated, what is the meaning of insulated? There is no heat transfer, and initially evacuated vessel is connected to this pipeline through a valve. The valve is now opened and the gas is allowed to fill in the empty vessel. There is an empty vessel and there is a valve, and this is the pipeline, let us say. This is how it is happening. The final temperature of the gas. So the gas is undergoing a process from 1 to 2. So the question is to find out final temperature. Here in the pipeline, pressure is Pi, temperature is Ti. And initial mass is equal to 0. Initially the tank is evacuated, so the mass in the tank is equal to 0, and there is no outlet. Here the fluid is entering, I for inlet, and there is no outlet, so exit mass is also equal to 0. The question is to find out T2. The question is to find out the value of T2. So if you know the standard value or the formula, T2 is equal to gamma times of Ti. T2 we will obtain as gamma times of Ti. Gamma is 1.39 and Ti, what is the temperature? 450 plus 273. So this is T2 in Kelvin. Do the calculation and you can convert it into degrees Celsius. Can you guys do the calculation? Those who did not get the answer, do the calculation. 450 plus 273. You don't forget to convert it into Kelvin, into 1.39. That is gamma, and minus 273. 1004.97. So T2 is equal to 1004.97 Kelvin. Your answer will be in Kelvin, but we need in degrees Celsius. So 1004.97 minus 273. That will be in degrees Celsius. What is the answer in degrees Celsius? Minus 273, 731.97 degrees Celsius. 731.97, D is the correct answer. But raise your hand, how many of you know how to get this expression? Those who know how to get this expression, please raise your hand. How to get this expression, this standard expression? Do you know? Because if I do some minute changes, will you be able to, this formula will not work. If I make some changes in the question, the formula is not going to work. The formula is applicable only when the tank is rigid, insulated and initially evacuated. These three things are important for this formula to be applied. Acha, well done Ludwig. And the other thing is there is no outlet in the tank. There is only inlet in the tank, but there is no outlet. So then we obtain this formula. Let me give you an understanding. So if we talk about the mass conservation, if we apply the mass equation for the tank, the mass entering minus mass leaving is equal to change in mass in control volume. That is M2 minus M1 in control volume. That is our mass conservation, the amount of mass entering into the control volume. Let me show you this. This is our control volume. This is inlet, let us say. This is exit, right? And the process undergone is 1 to 2. The process undergone by the tank. This is our control volume. So mass entering into the control volume minus mass leaving in from the control volume is equal to change in mass in the control volume. There is no outlet in the tank. There is no outlet in the tank. And initially the tank is evacuated. So what we get is Mi is equal to M2. That is one expression. The second is energy equation or first law of thermodynamics. So according to energy equation, we can say energy entering into the system minus energy leaving from the system is equal to change in energy of the control volume. That is energy conservation equation. E in minus E out is equal to change in energy in the system. Right? Energy entering minus energy leaving is equal to change in energy. Now how to write energy entering? Let me assume the heat is added to the system and work is done by the system. Heat is added to the system, that is taken as positive. Work is done by the system, that is also taken as positive. So how much energy is entering? Energy is entering along with the mass Mi, and energy is leaving along with the mass. Whenever the mass travels, it carries energy, isn't it? So what we will do is Mi into, because it is a flow process, Hi plus Ci square by 2 plus Gzi plus Q. That is energy entering minus energy leaving, that is Me into He plus Ce square by 2 plus Gz plus W. That is energy leaving. Energy entering is I plus Q. Energy leaving is E plus W is equal to change in energy in the control volume, change in internal energy, change in potential energy plus change in kinetic energy in the control volume. That is, so if we assume there is no change in potential energy, there is no change in kinetic energy is equal to 0. If we assume change in potential energy and kinetic energy as 0, and if we assume Q is equal to W is equal to 0. Why Q is equal to 0? Because the system is thermally insulated. Why W is equal to 0? Because it is a rigid. PDV is equal to 0. Rigid container will have 0 work transfer. So if we simplify this, Ci square, Ce square will become same. Change in kinetic energy will be 0. Potential energy will not be there. Change in potential energy will be 0. Q will be 0. W will be 0. So our expression will be MIHI minus MEHE is equal to change in potential energy. So change in internal energy M2U2 minus M1U1, isn't it? In the control volume 2 minus 1, because there is no outlet and the system is initially evacuated. So the expression will be Mi into Hi is equal to M2U2. U is the specific internal energy, and we have already proved that Mi is equal to M2. So these two will get cancelled out. So Hi is equal to Cpti, because it is an ideal gas, is equal to small u2 is Cv into T2. So T2 will be equal to Cp by Cv into Ti. Are you getting this? And what is Cp by Cv? That is nothing but gamma. Cp by Cv is gamma. So that is how we obtain this expression. This is how we get this expression. T2, the final temperature in the vessel or the tank will be gamma times. It is more than Ti, it will be gamma times of Ti. This type of questions had been asked previously number of times, and this is important concept which checks your ability to apply the mass conservation equation as well as the energy conservation equation. I hope this is clear. Can we proceed further? And again I am telling you, 8 o'clock sharp we will revise the first part of fluid mechanics formula. First part means the fluid statics and fluid kinematics, or the Bernoulli equation as well. All the formula we will discuss in an interesting manner through questions. So do witness this session. The session is at 8 p.m. sharp, and ask your friends also to join me at 8 p.m. today. So there are some more questions. Do not go anywhere. But there are some announcement. There are some ads in between. The next mega mock test is going to be conducted between 28th of October to 3rd of November. So do register yourself for the mock test, mega mock test, and the syllabus of the second mock test. It is subject-wise test, fluid mechanics, strength of materials, and power plant engineering. These are the subjects, and the pattern will be same as that of your GATE pattern. So do register yourself. The link to register yourself is already there in the description box. And based on your performance in this scholarship test, you can unlock our test series at a very cheap, very discounted price. So your performance will definitely matter, or your performance can fetch you some discount in our test series. It is high time you should practice more and more numericals as possible. All right. So do mark the dates in your calendar and do revise. This is how you can get motivated to revise your subjects. So do revise fluid mechanics, strength of materials, and power plant engineering before you appearing for the mock test. Let us move to question number 5. Question number 5th. Yes, give it a try. Solve question number 5th. Every one of you. We are halfway now. We are yet to have 5 more questions. Did you guys like the difficulty level of the question? Or they are not difficult at all? Do not expect highly difficult question in your GATE examination. GATE never asks you highly difficult question. They only ask the conceptual type of questions. So if your concepts are clear, you will be able to get the marks. So don't think that it is very difficult. They always prepare the question paper very difficult. No examination try to make the question paper which people cannot solve. Or what they only want to check is your understanding, your deep understanding of the concept. So the questions are slightly twisted from the normal formula based questions, but yes, the difficulty level, that makes the difficulty level little higher compared to PSU examination, engineering services examination, but still you can easily solve those questions. Yes, the next question, question number 5 on the screen. A certain quantity of a gas undergoes the polytropic process. What is polytropic? Polytropic process is when there is a heat transfer also, there is a work transfer also. From an initial state of 1.5 megapascal, initial pressure is 1.5 megapascal and initial volume is equal to 0.09 meter cube. To the final pressure P2 becomes 7.5 megapascal. The work done by the gas in kilojoule is, as the pressure increases, so the process is compression, isn't it? Because the pressure is increasing, the process is compression, and compression work is, what is the sign of compression work? Isn't it negative? Because work is done on the system. Compression work is negative because it is done on the system. Expansion work is positive. If it is a turbine, then the work will be produced. If it is a compressor, then work will be consumed. So compression work is always negative and turbine work is positive. I hope you are aware about the sign convention. So C and D cannot be the option for this. C and D cannot be the option for this. Now, for a polytropic process undergone by an ideal gas system, the gas by default it is an ideal gas because PV to the power n is equal to constant is the expression for polytropic process undergone by an ideal gas. Reversible polytropic process must be reversible and the system should be an ideal gas system. So W for a polytropic process is similar to, it is a closed system, it is similar to P1 minus P1 V1 minus P2 V2 upon n minus 1. The problem is with V2. But yes, we can find out V2. How? T2 by T1 is equal to P2 by P1 to the power n minus n by n, gamma minus 1 by gamma, similar to that, is equal to V1 by V2 to the power n minus 1. Isn't it? If you compare this, then this n minus 1 getting cancelled out. So we can say P2 by P1 to the power 1 by n is equal to V1 by V2. So we need to find out the value of V2. Or what we could have said, V2 by V1 is equal to, what is the value of V2? First of all, find out the value of V2. Find out the value of V2. Let me know the value of V2. This is our equation number 1. So can we say V2 by V1? Can we say V2 by V1? V2 by V1 is equal to P1 by P2 to the power 1 by n. So here V2 is equal to, what is V1? 0.09 meter cube. P1 by P2 1.5 upon 7.5, that is 1 by 5 to the power 1 upon 1.3. Isn't it? What is the value of V2? What will be the value of V2? First of all, find out the value of V2. Are you getting V2 as, are you guys getting V2 as 0.026? Those who are getting it, please raise your hand. Meter cube, the value of V2 should be 0.026. 1 by 5 is 0.2 to the power 1 divided by 1.3 into 0.09. It is 0.026, and if you put the value here, then it is just the formula based question. Put the value of V2, then work for a polytropic process is given by P1, that is 1.5. Another important thing, if you want it in kilopascal, kilojoule, if your options are in kilojoule, then pressure should be in kilopascal, isn't it? So what is 1 megapascal is equal to 1000 kilopascal. Convert this megapascal into 1000 kilopascal. So 1.5 megapascal is how much? 1500 into V1 0.09 minus 7500 into 0.026 upon gamma minus 1, isn't it? N minus 1, that is 1.3 minus 1. This will give you kilojoule. If the pressure is in kilopascal and volume is in meter cube, then it will, pressure into volume will become kilojoule. So that will give you the answer. What is the answer? It will be negative. Definitely it will come out to be negative. So 7500 1500 into 0.09 divided by 1.3 minus 1, that is 0.3. So 202.39 something, 202. Are you getting exactly 200? It is very much close to 200 kilojoule. It is very much close to 200 kilojoule. So that is why The correct answer is option B. B will be the right answer. I hope you understood this. Question number 5. Question number 6 and 7, linked questions. Very, very beautiful questions. 6 and 7. Question number 6 and 7. Let us read the questions and try to solve. An insulated vertical cylinder. This is the cylinder. This is insulated. An insulated vertical cylinder enclosed 0.1 kg of argon. Mass of the argon is 0.1. With the help of a frictionless non-conducting piston as shown in figure. There is a piston. This is the piston. The mass of the piston is 5 kg. Mass of the piston. And it is initially rest on the bottom of the cylinder. Initially it is here. Initially it is here. This is the initial position. This is the final position. This is how it is moving. Isn't it moving? So initially it is at bottom, then it is moving in upward direction. When it is moving, the cylinder is connected to a nitrogen tank. This is the tank. This is the tank. It is the nitrogen tank which is at 100 bar through a pipeline fitted with a valve. There is a valve. This is the valve. The valve is opened and the nitrogen is slowly admitted into the cylinder. Nitrogen enters into the cylinder. That is why the piston is moving in upward direction. During this operation, the piston is lifted through a height of 10 cm. This is 10 cm. The piston is lifted by a height of 10 cm by the nitrogen gas, right? Because nitrogen is at very high pressure. That is why the lifting of the piston will take place due to entering of the nitrogen gas. The initial pressure and temperature of argon gas are 100 kilopascal. That is P1. That is T1. The final temperature, that is T2. For argon, Cp and Cv are given. Now the question starts. Is the statement clear? Is this all clear? दीपक, गुड इवनिंग. मनिकेत, वेलकम. लेट कैसे हो गए? 8 बजे जरूर ज्वाइन करना मुझे. एवरीवन, दीपक, मनिकेत, प्रांतल, देव, टुडे at 8 PM formula memory for fluid mechanics. Okay, after this class. So the question is, sixth question is, the work done by the argon in kilojoule during the process is. The work done by the argon in kilojoule during the process is. So it is thermally insulated. It means there is no heat transfer and argon is an ideal gas. So can we call the process 1 to 2? Can we call the process 1 to 2 to be reversible adiabatic? Argon is an ideal gas. So in the cylinder, argon gas is undergoing the process. Yes, part 1. Thank you, Deepak. Thank you for your nice words. That always gives us the motivation to bring the sessions in more interesting, simple and fruitful manner. Yes, this is what we require from your end. We do not want anything else but your motivation, your participation and your selection at the end. That is our objective. The work done by the argon. So the argon is undergoing a reversible adiabatic process, isn't it? Because Q is equal to 0, isentropic. So W122 is equal to, can we write P1 V1 minus P2 V2 upon gamma minus 1? Isn't it? P2 V2 is not given. V2 we cannot calculate. Why we cannot calculate V2? Because area is not given, area of the piston is not given. So can we write it as MR into T1 minus T2 upon gamma minus 1? So W122, what is the answer? What is the answer? W122 is M for argon into R can be written as Cp minus Cv into T1 minus T2. T1 is given as 300, T2 is 320. 300 minus 320 upon gamma is Cp by Cv minus 1. Put the value. What is the mass of argon? Mass of argon is 0.1 kg into Cp minus Cv. Cp is 520, Cv is 312 joule per kg Kelvin. (520 minus 312), then that is minus 20 upon Cp by Cv. 520 by 312 minus 1, that will give you joule. This will give you joule. If you want in kilojoule, you can get, because it will give you negative work. Why? Because it is compression, reversible adiabatic compression. Because it is a compression process, that is why positive cannot be the answer. Positive value cannot be the answer, right? It cannot be positive. I hope this is clear. So can you get me the answer? Are you getting option C or not? Everyone. नहीं, today's part 1, part 2 today कैसे हो जाएगा? Today's part 1. अच्छा, part 2 लिखा हुआ क्या? Today will be part 1. मैं अभी थोड़ी देर में आपको लिंक भेज दूंगा अपने अच्छा, आपने फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स अप्लाई कर दिया, ये भी ठीक है. Q इज इक्वल टू डेल्टा U प्लस W. Q इज इक्वल टू 0, सो W इज इक्वल टू माइनस डेल्टा U. सो W इज इक्वल टू माइनस, ये भी तरीका सही है, माइनस M इंटू M ऑफ आर्गन इंटू CV इंटू T2 माइनस T1. So it will be minus 0.5, sorry 0.1. That is another approach. Minus 0.1 into Cv is 312 into T2 minus T1, that is 20. That will give you joule. This is better approach. ये भी यूज कर सकते हैं या ये यूज कर ले, इसी से आता है ये एक्सप्रेशन. 312 into 20 into 0.1, 624, that is in kilojoule minus 0.624. Now the next part is correct Prantal. ऊपर वाला ही सिस्टम है, सिस्टम हमारा यही है. दिस इज आवर सिस्टम. Now the work done by the nitrogen in kilojoule during the process is, nitrogen किस पे वर्क कर रहा है? The work done by the nitrogen, एक तो सिस्टम की बाउंड्री पे वर्क कर रहा है. The work done by the nitrogen in compressing the system, and other than that on the piston also, there is a mass of the piston. The mass of the piston is, the weight of the piston is acting in downward direction. So the work done by the nitrogen is how much? The work done by the nitrogen is, work done by the nitrogen is to compress the system plus to raise the piston weight, to raise the piston weight by 10 centimeter. This is the total work done by the nitrogen. This will be the total work done by the nitrogen to compress the system. So whatever is the work done on the system for compression, W compression will be equal to the work done by the nitrogen, because the nitrogen is doing the work. It means work is done by nitrogen, it will be positive. So plus 0.624 kilojoule we have already obtained, 0.624 kilojoule, plus to raise the piston. So mass of the piston into G into H, this is extra work done, mass of piston into G into H. That will be the total work done. So the work done will be equal to, let me write here, the work done by nitrogen is equal to 0.624. It is in kilojoule. So mass of the piston is, what is the mass of the piston? The piston is having a mass of 5 kg. Piston is having a mass of 5 kg into 9.81 into 10 centimeter, that is 0.1, divide by 1000. Why? Because we want it into kilojoule. So can you get me the answer? 0.629 kilojoule. Are you getting? Work done by the nitrogen will be 0.629 kilojoule. 0.629 kilojoule will be the work done by the nitrogen gas. If anybody is having any doubt, anything to ask, you are most welcome. Let us move to the next one. Question number 8. It is simple. I want everyone of you to give it a try. Then the next question is simple. The compressibility factor we need to calculate. Compressibility factor. We need to calculate the compressibility factor. What is compressibility factor? That is the measure of deviation. It is the measure of deviation from ideal gas behavior. Compressibility factor is the measure of deviation from the ideal gas behavior. So we can say Z is equal to 1 for ideal gas. For ideal gas, Z will be equal to 1, but Z is not equal to 1 for real gas. So if Z is not equal to 1, it means it deviates from the ideal gas behavior. So more will be the value of Z, more will be the deviation from 1. 1 is the value for the ideal gas behavior. And what is the ideal gas equation? Ideal gas equation is pressure into volume is equal to MRT, isn't it? So pressure into volume is joule, MRT is also joule. Right, left hand side is having the SI standard unit as joule, right hand side is also having the standard unit as joule, isn't it? So Z is equal to, the compressibility factor is equal to PV, pressure into volume, upon MRT. This is what is. So for an ideal gas, PV is equal to MRT, so that will be equal to 1, is equal to 1 for ideal gas, otherwise it will be PV by MRT. So you should take care of the units. If you put everything in their SI unit, Z is equal to, what is the pressure? Pressure of the gas 18.56 megapascal. So 18.56 into, let me write 10 to the power 6 Pascal, into volume. What is the volume? Volume is 6.4 liters. So 6.4 into 10 to the power minus 3, isn't it? 1 liter is equal to 10 to the power minus 3 meter cube. Put all the parameter in their SI unit. Divide by what is the mass of the methane? 1 kg into R. R is equal to R bar by molecular weight. R bar by molecular weight. And what is R bar? R bar is 8.314 kilojoule per kilomole Kelvin. So 8314 joule per mole Kelvin. Joule per mole Kelvin. Into molecular weight. What is the molecular weight of methane? That is 16 kg per kilomole. So 16 kilogram per kilomole. Convert it into kilomole, should be converted into mole. So it will be 0.016 into temperature. Temperature should be in Kelvin, 273 plus 13. Can you solve it and let me know the answer? It should be 16 into 10 to the power minus 3. Do you get it? It will be 16 into 10 to the power minus 3 because it is in kilojoule per kilomole. So you should put all the parameter in the SI unit. That is important. In this question, more important is the unit. How to convert one unit into another. This 10 to the power 6 getting cancelled out with this. What is the value of Z you will be getting? Are you getting something around 0.799? Are you guys getting 0.799? That is 0.8. B will be the correct answer. B will be the right answer. I hope you are able to understand the conversion of the unit. It was in megapascal, I have kept it in pascal. Similarly, it was in kilojoule per kilomole Kelvin. Sorry, it will be 8.3, sorry, my mistake. It will be 8.314 only, isn't it? It will be 8.314 only. It will not be 8314. मैंने गड़बड़ कर दी ना. 18.56. 18.56 multiplied by 6.4. 8.314 ही तो होगा, क्योंकि किलोजूल को भी जूल में कन्वर्ट कर दिया और किलोमोल को भी तो मोल में कन्वर्ट कर दिया. सो इनटू 6.4 इनटू 16 डिवाइड बाई 8.314 इनटू 273 283 286 0.79 है, तब आएगा 0.79 है. If you put 8.314, then you will get 0.79. So इसकी मैं बात कर रहा था फॉर्मूला मेमोरी टेस्ट. So we are starting from today. ये थोड़ा सा minute changes है इसमें. Today it will not be strength of materials, but today it will be fluid mechanics part 1 and tomorrow fluid mechanics part 2. The timing will be 8 p.m. and tomorrow also 8 p.m. So today and tomorrow fluid mechanics will be there, and then there will be strength of materials on Saturday. Saturday is strength of materials. 28th. So at 9 p.m. So this is the changes. Let us move to the next question. Question number 9. मनिकेत ये क्वेश्चन सॉल्व करिए. कई बार होता है जब दूसरा कोई क्वेश्चन सॉल्व करता है तो दे लुक्स वेरी इजी, बट व्हेन यू स्टार्ट सॉल्विंग द क्वेश्चंस देन द डिफिकल्टी एक्चुअली अराइजेस. सो यस, ट्राई टू सॉल्व दिस वन. एवरीवन प्लीज गिव इट ए ट्राई. तो ये सूडो कॉन्फिडेंस इज वेरी डेंजरस. It is very common phenomena. When you are seeing the solution in front of you, you find the question very easy, right? Because everything is written step by step, or somebody else is solving. The question looks very simple, but actually they are not that simple. These questions are not very simple. They are not very tough, but they are of moderate type, which you can expect in your GATE examination. सॉल्व करिए. सॉल्व किसको 4 बजे कर दूं? एफएम का टाइम. एयर आर इज गिवन एज 287, सीपी इज गिवन, गामा इज गिवन, फ्लोज सीक्वेंशियली थ्रू ए कंप्रेसर. पहले कंप्रेसर में से गया, देन ए हीटर एंड देन ए टर्बाइन. एज शोन इन फिगर. वॉल्यूम फ्लो रेट ऑफ एयर कमिंग आउट फ्रॉम द कंप्रेसर इज गिवन एज दिस. वॉल्यूम फ्लो रेट मतलब discharge coming out from the compressor is given as this. When the pressure and temperature are 276 kilopascal, everything is given, and temperatures, when pressure and temperatures are given, air then heated at the same pressure to 430 degrees Celsius is the temperature after the heater. Now the pressure remains constant. P is constant. It is a constant pressure, 276 kilopascal. From heater, the air flows through a turbine. Our objective is to analyze this. This is the turbine. This is our system. From heater, air flows through a turbine which produces 1860 kilowatt of power. The power developed is equal to 1860 kilowatt. Units are important. Heat loss from the turbine to the surrounding. There is a heat loss. Heat added is positive. So Q is equal to minus 90 kilowatt. Isn't it? Air temperature at the turbine exit. If we call the turbine inlet to be 0.1 and the turbine exit to be 0.2. So T2 to be calculated. The question is to calculate T2. Yes, definitely the question will be solved from steady flow energy equation. This is our system. This is 0.1, this is 0.2. So if we apply steady flow energy equation, so we can say H1 plus C1 square by 2 plus GZ1 plus Q is equal to H2 plus C2 square by 2 plus GZ2 plus W. Isn't it? There is no change in potential energy. There is no change in potential energy. There is no change in kinetic energy across the turbine. So we can say H1 minus H2. So H1 minus H2 is equal to W minus Q. What is the unit? That is kilojoule per kg, isn't it? That is kilojoule per kg. But if we multiply by the mass flow rate, so can we write m dot mass flow rate into Cp into T1 minus T2? Can we write mass flow rate, multiply with mass flow rate, then Cp into T1 minus T2 is equal to mass flow rate into W, that is power, minus mass flow rate into Q. So that will become kilojoule per second, because mass flow rate is kg per second. So our objective is to find out the mass flow rate, that is 1860. The power developed is 1860 kilowatt, and minus Q is equal to minus 60. That will be kilowatt. So mass flow rate to be calculated, Cp is 1005 because it is in kilowatt. So we can write it as 1.005. Then only it will become, and T1 is 430. What is 430 plus 273? 430 minus T2, because it is the difference. So you can take in this expression. So our objective is to find out the value of mass flow rate. Can you solve for mass flow rate? Can you find out the value for mass flow rate? How to calculate the mass flow rate will be calculated from here. Mass flow rate is equal to rho into Q, or volume flow rate. So density can be written as P by RT into Q. This is Q. Q is given. P by RT into Q. What is the pressure? 276 kilopascal into 2.33 upon R. What is the value of R? 287 joule. If we want it in kilojoule per kg Kelvin, so 0.287 into temperature is 43, 273 plus 43. That will give you the answer. What is the mass flow rate? Your mass flow rate should be 7.09 kg per second. If you are getting the mass flow rate, that remains constant. Mass flow rate will remain constant. Put the value in equation number 1. If you put the value in equation number 1, then you will get the answer to be 156.4. So see you at 8 o'clock. This was question number 9, right? And this is your assignment question. Question number 10 and 11 will be your assignment question. Yes, 10th and 11. Please try to solve at home, and tomorrow we will continue. So there is a crash course running on your BYJU'S platform, paid course. You can join our crash course. You can join the long-term batch as well, and formula memory test at 8 p.m. today. We will have this session, and tomorrow the next class tomorrow will be from the second law and entropy. Tomorrow we will discuss some wonderful question from the second law and entropy. So do join me tomorrow at 6, and do not forget to join me today at 8 o'clock. So that is all from my side, guys. Thank you very much for joining in. Take care. I will share the PDF of this session to my Telegram channel, and if you are not part of my Telegram channel yet, please do join using the QR code or using the link mentioned there. Thank you and Jai Hind. See you at 8.